Hi, 8th graders. Today we're moving on to section 9.2, which deals with relations. Now, yesterday's assignment, we had what was called the one-to-one correspondence. And basically that said that for every one value of x, I had an equal value for y. Okay, so it was 1-to-1. And the thing that creates is a relation, or it's a set of ordered pairs. Okay, and so when we have a relation, it is often written as a set. Okay, so remember when we did set notation in that at the beginning of the year, how we had a set with brackets, and then we had our different points inside with parentheses. Okay, here we're going to name our set with a capital letter. Okay, so I have set A, which is made up of 4 coordinates here. Now, if I were to graph my coordinates, I'd see that there was some kind of relation between them. It was maybe a vertical line or a line of some sort, okay? So we just know that anything that is inside this set has something in common, okay? Now, with relations here, we have 2 things, okay? We have what is domain and range, okay? Domain is the set of all the x coordinates. So looking up here, I'm going to look at all my x coordinates, and they're going to go inside this domain of D. Okay, my set D is for the domains. Now, if you notice, they're not in order to this relation up here. When I do set notation for my domain and my range, I am going to go from least to greatest. Okay, now domain, it was all the x coordinates. Range is going to be my y coordinates. Okay, now if you notice, I went from least to greatest, but I have a little notice sign over here. I did not repeat the same number here. Okay, so if you notice up here in my relation, I have 2 y coordinates that are -3. I only wrote it one time here, okay? So when I write domain and range, I write them from least to greatest, and I do not do repeat numbers, okay? So the big thing to remember is domains are always my x, range are always my y. Okay, so let's take a look here. I have set A, and I want to find the domain and range for it. So I'm going to create the set, D for domain, do my squiggly here, it's my bracket, and now I'm going to look for all my x values because I'm doing domain. And so I've got 1, -3, 2, and 4. Now I need to order them from least to greatest. So I'm going to start with -3, comma, 1, comma, 2, comma, and 4. Okay, that is my range, my domain, sorry. Now we're doing my range. My range are all my y's. So R, my set R for the range. Now let's take a look. I've got 10, 9, 5, and -3. So I need to put them from least to greatest and complete my set of y, which is my range. Okay, let's do one more here. And let's do set B here. Okay, I'm looking for my domain. Domain stands for all the x values. So I've got -3, -4, -3, and 8. Okay, so I've got to range them from least to greatest. And so I'm going to start with -4. Remember, the bigger the negative, the actual smaller it is. So I'm going to start with -4. And then I've got -3. But if you notice, I've got 2 -3s. I'm only going to write it one time. And then I'm going to finish off with 8. Okay, so that would be my domain. My range are my y values. And so my y value are 5, 6, 10, and -6. So I'm going to start off with the -6, 5, 6, and 10. Okay, so that's finding the domain and range from a set situation here. Okay, now remember, a relation isn't always written as a set of ordered pairs. Sometimes the relation is defined by an equation. And our job is to find the ordered pair for that set. And so that's what we're going to be working on next here, okay? So here I have my example. And my example says, write the set of ordered pairs for the relation G. If y equals 2x for each ordered pair and the domain of the relation is negative 2, 0, 1, and 3. Now remember, what is domain? Domain is always my x values. So the very first thing I need to do is I've got to find the y coordinates for my domain. Okay, so here in a way I set it up going across and I rewrote my equation 4 different times. Another way to do it to help keep it organized is to set it up in a table. And so what I'm going to do here is put y equals 2x, since that's my relation. I'm going to find my y value and then find my ordered pair. Okay, and so then they give me my x's here because they're the domains, remember? So I've got 2, 0, 1, and 3. So I'm going to go ahead now and substitute x into my equation. So 2 times a negative 2 is negative 4. The ordered pair, remember x always comes first, and then I put my y. Okay, and then for the next one I would substitute 0 in, and then make my ordered pair 0 and 0. And then I would do the next, substitute my x in, and I'd get 2. My ordered pair would be 1 and 2. And do the last one, and I get 6. My ordered pair would be 3 and 6. Okay, so it is however you would like to set things up. Would you like to set it up this way? Does it make sense for you? Or does it make more sense for you to set it up as a table? It's whatever's more visual pleasing to you and easier for you to work with. Our last step is to go ahead, and they want it as a set. It asked me for the relation of G here. So the very last thing I needed to do was put it in as a set. So I had to write G equals and then list these ordered pairs here, just like I did up here. And remember, when I end my set, I always have to end with a back bracket. Okay, so last thing here, let's do a practice here. Okay, let's do, if the domain of a relation H here is negative 3, 1, and 5, find the ordered pairs x and y for the relation H when y equals x minus 1. So it's going to be the same thing, okay? My x values, they give me as negative 3, 1, and 5. The relation they give me is the equation y is x minus 1. I need to find what y is, and I also need to have the ordered pairs. Okay, so now we just put it into our equation. X I put in as negative 3. I get y to be negative 4. And my ordered pair is going to be negative 3 and negative 4. Now substitute 1 in for x. And I find out I get 0. X always comes first in my ordered pair. And do the last one, substitute 5 in for my x. And I find out 5 minus 1 is 4 for my y. Ordered pair, x comes first, then y. And so there's my ordered pair. Now the last thing they want me to do is find that relation. So I'm going to put it up in set notation for H, and then I'm going to list my ordered pairs. Okay, don't forget the commas in between them. And I end up with this set right there. Okay, so all of these situations that we have worked with have had ordered pairs. Now, what happens if, we can't go that far, we forgot about graphing here. Okay, so remember, we practiced graphing yesterday. Graphing, we have my x and my y, okay, coordinates. X is always horizontal, y is vertical. Remember, we're going to find where we are on the lines and graph our points here. For set A, I start off at -3 and I go up to 6. Okay, just up here. Go to the next one, -2 up to 4. Okay, go to 0, 0. I've got 2 and -4, 2, 3, 4, and then I end up with 4 and -6. Then I use a straight edge, and mine is not going to be very straight because I did not use a good axis here. But there is the graph of set A. Okay, so the last thing we're going to now talk about is what happens if they give me a relation and they don't have any coordinates. I just have a line. Okay, if you notice here, I'm supposed to give the domain and the range, but I don't have exact coordinates. But I do have where the ending and the beginning points are. So what I'm going to do is I'm going to, for my domain is always my x value. So I'm going to write x is between my smallest value for x, which is over here at -2, and then I'm going to put it where it's my biggest x value, which is 0. So I can write it as an area here, okay? It's basically an inequality because I can have anything on this line. Okay, because I can have like 0.25s. I could have 0.175. There's a lot of points on here. And so this takes care of all my x values. And then I'm going to do the same thing for my r, okay? R stands for my y values. And so same thing, my y has to fall between the lowest, the smallest value of my y, which is -1, and y has to fall between to the highest point here, which is 2. So I have inequalities here that tell basically what my range and domain are going to be. I can go ahead and graph these by same thing, plotting the endpoints of them and connecting them with a line. Okay, guys, this is how we work with relations with graphing. Okay, remember, x is always horizontal, y is vertical, x is always domain, and y is always my range. Okay, guys, have a good day.